Secretary sir has joined. So shall we start, sir, with your permission? Sir, your mic is mute. Okay. Shall we start, sir?
Yes, we can start. Can you hear me?
Thank you. So, respected Chairman, Digital Communication Commission and Secretary Telecom, Dr. Neeraj Mittal, sir. Respected Member Services, Sri A.K. Sahu, sir. Advisor, Telecom Engineering Center, Ritu Ranjan Mittal, sir. Director General NTI PRIT, Sri Dev Kumar Chakrabarti, sir. All senior officers, my colleague, and most important, dear participants. Good morning to all of you and warm welcome to this webinar on 6G usage scenarios, key capabilities, and its potential technology. So let me just give you a brief about the webinar quickly through this PPT, which you can see on the screen. So in this session, after the inauguration session, we have 3 technical sessions on technology vision for 2030, evolution from 5G to 6G. Second session is potential technologies of 6G. And the third session is 5G advanced technologies and their evolution to 6G. So today we have distinguished dignitaries, Dr. Neeraj Mittal, Secretary Telecom. We have Sri Ajay Kumar Sahu, Member Services, DOT. We have R.R. Mittal, sir, Advisor, Telecom Engineering Center. We have DG NTI PRIT, Dev Kumar Chakrabarti, sir. And we have 3 expert speakers, sir. Professor Kiran Kuchi from IIT Hyderabad, Sri Satish Kanugovi from Nokia, and we have Dr. Puneet Rathod from Qualcomm for the 3 technical sessions. So with this introduction, may I now request my DG Dev Kumar Chakrabarti, sir, for a welcome address. Over to you, sir.
Thank you, Ashok. A very good morning to everybody. On behalf of the NTI, the nation's premier institute for telecom training, policy research, and innovation, I extend a warm greeting to you all. You are aware that one of the prime jobs of the NTI is to conduct national and international training programs, seminars, webinars, workshops, etc. on the latest technologies, technological issues, and help create a collaborative learning and awareness about the.
Sorry, go ahead.
Okay.
Go ahead, sir.
Fine. And their usage along with creation of a knowledge bank. In fact, it's a matter of a great pleasure to inform you that NTI has created a huge content under the mission Karma Yogi, and it has been rated as one of the top 3 contributors in IDOT, that is the Mission Karma Yogi platform. Again, towards creating the capacity building among all the stakeholders, NTI has been accredited as an NSC STI, that is National Standards for Civil Service Training Institution by the Capacity Building Commission of India. It is one among the first 8 such institutions in our country. In the international arena, NTI has been closely working with the international telecom bodies like APT, ASEAN, ITU, etc. Again, it's a matter of great delight that recently NTI has been recognized as an ITU Academy Training Center. This is one among 14 such institutes all over the world. Today, we are conducting a webinar program spread over the first half of the day on a very important topic, 6G usage scenarios, key capabilities, and potential technologies, and mostly catering to the national audience. In fact, NTI conducts webinars once in every fortnight. But this one is very significant because we are talking about the technology of tomorrow, where India is aspiring to become the frontline contributor in 6G technology and manufacturing by 2030. In such an all of the nation approach, it is essential that every stakeholder, industry, startups, academia, the research laboratories, standardization bodies, the citizens, and the government come together, collaborate, and contribute to the global good. Our today's webinar is one more step towards this. At the outset, I welcome the Honorable Secretary Telecom and the Chairman DCC, the Government of India, Dr. Neeraj Mittal, for sparing his valuable time and giving his kind consent to join us and deliver the inaugural address on the occasion today. I welcome Honorable Member Services BCC, Sri Ajoy Kumar Shahu, for kindly consenting to join us and deliver the special address in this webinar today. I also welcome respected advisor TEC, Sri Ritu Ranjan Mittal, for kindly consenting to join us and deliver the special address in this webinar today. In this webinar today, we have three very eminent and expert speakers, one distinguished professor from an IIT, and two industry leaders from two of the globally leading telecom R&D giants, that is Qualcomm and Nokia. I heartily welcome the first expert speaker, Professor Dr. Kiran Kumar Purji from IIT Hyderabad and the founder of YSEED Networks. I heartily welcome the second expert speaker, Sri Satish Kanugovi from Nokia. He is presently functioning as the head of the Standardization and Industry Engagement APAC Nokia. I also welcome the third expert speaker, Dr. Puneet Rathod, the lead technical standards of Qualcomm. We have got a big response to this webinar on the 6G technologies today. It is very heartening to see that more than 400 participants have already registered as on yesterday and participating today in this webinar. On behalf of NTI-PRIT, I welcome each and every participant. Finally, while welcoming everyone again, I wish a very meaningful webinar today with the participation of such a distinguished gathering. Thank you very much. Thank you.
Thank you, sir. Thank you, sir, for setting the tone for the webinar. All of us are aware that Secretary Sir has got another meeting, and his time is very, very valuable. So without wasting much of the time, may I request respected Secretary Telecom for his inaugural address. And rest of the session will do after your address, sir. So over to you, sir.
Thank you so much, Dev sir. So first of all, I thank the NTI-PRIT to have invited me to give this inaugural address. I would like to start this, by first welcoming all the people here. Shri Dev Kumar Chakrabarty, Mr. Sahu, Member Services, Shri Ritu, Shri Satish, Professor Kiran Kumar, Dr. Puneet Rathod, and all the other members and participants of this seminar. Albert Einstein once said that, it's becoming appallingly clear that technology has exceeded our humanity. And today's seminar essentially is a reminder of that statement, which was made, several decades ago, that the technology continues to surprise us with more and more capabilities. And we sometimes feel dwarfed by our own capabilities as humans as to what technology can do for us. If you see the rate of change of technology, it has become exponential in the last few decades. And one is not able to actually predict where we will be in 5 years from now. This time span would have been a decade a few years ago. It would have been possibly 15 years before that. But this time period is becoming shorter and shorter as we are evolving, as technologies are evolving. Communication technologies from the early days of 2G to now we are talking of 6G. I think in the same generation of we are all here, we have looked at 2G, 3G, 4G, 5G, and now 6G. So therefore, I think this seminar is really, really very important today, and it is bringing all the experts from various institutions to deliberate on the new standards, etc., which are going to come and define this new development for the rest of the world. The Working Party 5D of Study Group 5 under ITUR has approved the vision and framework for IMT 2030 in their meeting, and it envisages about 6 usage scenarios, which 3 are enhancement of 5G and 3 are new usage scenarios. The new usage scenarios include ubiquitous connectivity, which was championed by India at the ITU, integrated AI and communications, integrated sensing and communications. The Department of Telecom has taken a lot of steps to integrate and accelerate the 6G research and innovation in the country so that we can contribute as the original contributor to the 6G technology development and manufacturing by 2030. It set up a technology innovation group with members across the supply chain to develop the vision, mission, and goals for 6G and how to deliver this in India. They constituted 6 task forces focusing on multidisciplinary innovative solutions, multi-platform next generation networks, spectrum for next generation requirements, devices, standards contribution, and funding research and development. These task forces have deliberated and they are focusing on the innovations that leverage these new technologies to subsequently enable the Bharat 6G mission. Based on the report of the Technical Innovation Group and other strategic reasons, Bharat 6G vision was unveiled by our Honorable Prime Minister on 23rd March 2023, which aims to position India as a leading global player in 6G technology ecosystem. Its vision statement says, design, develop, and deploy 6G network technologies that provide ubiquitous, intelligent, secure connectivity for high quality living experience for the world. So I think the importance on high quality living experience is the defining criteria. Technology is only it's a means to an end and not an end in itself. Therefore, the vision is based on the principles of affordability, sustainability, and ubiquity. In furtherance to this objective, the Bharat 6G Alliance is a collaborative platform which aims to promote the ecosystem for research, design, development, IPR creation, and manufacturing, amongst others. The importance of Bharat 6G Alliance is seen when we signed an MOU with the ATIS Next Generation Alliance of the United States of America. And we will be able to work together, leveraging global supply chains toward this end. The Department of Telecom, on its side, has recognized that funding of new innovations is important for this 6G ecosystem to come up. And due to the sustained efforts of Government of India and our Honorable Prime Minister, innovation has become a very respected activity in the recent 5 to 8 years. And the Department of Telecom also launched the Telecom Technology Development Fund to promote the ecosystem for research, design, concept testing, and IPR creation in telecommunication field. We have already signed 2 agreements, 6G terahertz test bed with orbital angular momentum and multiplexing, and advanced optical communication test bed under this scheme. The other scheme which is relevant to all the stakeholders is the Digital Communication Innovation Square scheme to promote, again, the similar objectives through innovation in modern technology adoption. With these few words, I would like to thank NTI-PRIT for hosting this webinar on 6G use cases, key capabilities, and potential technologies. There are eminent speakers, illustrious technologists who are here today. And we, as Government of India policy-making body, we look forward to your advice, guidance, and recommendations for making India a leader in this world, in this technology and in this technology of mass use, adoption, and improving the quality of standard of living of Indians, and as a global supplier of technology for the rest of the world. I wish you all the best and declare the webinar open. Thanks a lot.
Thank you, sir, and thank you for your guiding words. You talked about 6G vision, DUT initiatives in this direction to accelerate all the activities. So before you leave, sir, I request Atul Sinha, sir, to offer a vote of thanks. You came in the webinar, sir, in spite of your busy schedule. So over to you, Atul, sir, for a brief vote of thanks for Secretary Sir.
Thank you, Ashok. Honorable Secretary Telecom and Chairman Digital Communication Commission, Dr. Neeraj Mittal, sir. Respected member services, advisor TEC, DG NTI PRIT, distinguished speakers, and esteemed participants, ladies and gentlemen. Very good morning to all of you. I take this opportunity to extend my heartfelt thanks to our esteemed Secretary, sir, for gracing this occasion with his presence and for delivering such an insightful and inspiring inaugural address, which has really set the tone for the deliberations in webinar. Sir, your vision and leadership in advancing the telecommunication sector in India are really going to be very, very inspiring for all of us. The kind of interest that you have taken only after a very few days of joining office in Department of Telecom as secretary, that is really very great of you, sir, that you took out time from your busy schedule, also took interest to inaugurate this webinar. We are really very thankful at NTI PRIT, sir, for your kind presence in this webinar. We are deeply honored to have privilege of hosting such distinguished speakers and panelists who have generously shared their expertise and knowledge during this session. And I would also like to express my sincere gratitude to all the experts, academics, and industry leaders who have joined us today from various corners of the country. Your participation enriches our discussion and brings a global perspective to this important forum. And finally, I would like to thank my colleague, Mr. Ashok Kumar, DDG NTI PRIT, and his team who have worked behind this webinar. Your dedication, hard work, and meticulous planning have ensured the smooth execution of this event. It is your relentless commitment to excellence that has brought us all together here today. And as we embark on this journey of exploration and discovery into the realm of 6G, let us carry the spirit of collaboration, innovation, and determination with us. The insights shared in this inaugural session have set the tone for what promises to be an enlightening and productive webinar for the half-day long session. Once again, thanks everybody for your valuable contributions and for being a part of this exciting endeavor. I once again take this opportunity to thank our Honorable Secretary Telecom and Chairman Digital Communication Commission, Dr. Neeraj Mittal, our member services, Shri A.K. Sahu sir, Advisor TEC, Shri R.R. Mittal sir, DG of NTI PRIT, Shri D.K. Chakrabarti sir, and we look forward to enriching discussion and insight that lie ahead in the coming session. Thank you, everybody. Thanks and good day. Have a good day and a wonderful webinar for the day. Thank you.
Thank you,
Sir.
Atulji.
Thank you so much, sir. Sir, we will start our rest of part of the inaugural session, sir. So next in line, we should invite our respected member services, A.K. Sahu, sir. Sorry, maybe I can take Advisor Telecom Engineering Center first. So may I invite Ritu Ranjan Mittal, sir, for his special address. So R.R. Mittal, sir, if you are.
So thank you, Ashok. So respected Dr. Neeraj Mittal, Secretary DOT and Chairman DCC, Shri Sahu, Member Services DCC, Mr. Dev Kumar, DG NTI PRIT, Mr. Satish from Nokia, Dr. Kiran Kuchi from IIT Hyderabad and also founder of iSig Networks, and Dr. Puneet Rathod from Qualcomm, our expert speakers of the day, and of course, dear participants. It is indeed heartening to know, and this webinar on the 6G is very timely, as Secretary Sir just mentioned that the Working Party 5D in its 44th meeting in June finalized the the framework document. The framework document has many chapters, and the chapter 3 relates to the usage scenario, and the chapter 4 relates to the capabilities. Now, usage scenario in as far as 5G was concerned, we had 3: enhanced mobile broadband, massive machine type communication, and ultra reliable low latency communication. Now, for every usage scenario, there are a capability set. So the old capability sets are peak data rate, user experience data rate, connection density, and so on and so forth. So they basically, the capability set define what will be the what usage scenario they are going to serve. So that is one part. Now in the 6G, we have 3 more usage scenario, as you will even in the brochure they've been well covered. So I will not go into that detail. One or two things are important as we move forward. Now the framework document has come. The rest of the time frame is very important, that we all know. The rest of the time frame is that by 2026, the ITUR will formalize the technical performance requirements for 6G. And also it will give a methodology how will any 6G candidate technology will have to be evaluated. And then from till 29, it will accept, it will give the technology, it will kind of accept technologies which are candidate technologies for the evaluation. So evaluation will be done in those last 3 years. It is Secretary already mentioned the initiatives of the government, the TTDF fund. It will also be appropriate to add here that recently DOT has entrusted CDOT to be to facilitate IP for those startups who want to file IPs or IPRs. They must get sufficient help. So that responsibility as a front-ending organization has been given to CDOT. On part of TEC, I can tell you that what we have started is we have made a portal wherein we are tracking all the 5G and 6G candidate technologies. Now, in a patent, there is no, when you cannot track something on a 6G, so there are candidate technologies, maybe let's say massive MIMO, or there may be so many technologies. So that we have started tracking with respect of, and we are tracking Indian Patent Portal, WIPO, which is from the Geneva, and also the US Patent Portal. And we have formed the expert group so that at one point of time we get guidance on which keywords to track for our updating how many patents have been filed in respective technology. So that is part of the TEC effort. Another thing I would like to suggest here is that NTI-PRIT also has a responsibility of policy research. So maybe a webinars on policy research would be very useful, because 6G as a technology is not going to come in a shot. There will be multiple technologies in various domains. So what policy initiatives DOT can take, I think NTI has a very important role to play. You know, for example, should we allow a technology in a private network and just see whether it satisfies? So those policy initiatives, what it could be, those inputs, I think NTI-PRIT will be, through their, I'm just suggesting webinars on the policy research related to 6G should be very useful. And I'm thankful to NTI-PRIT team led by Dev Kumar to have invited me for this talk. I welcome, I'm sure that the expert panel that you have here, we will have a very, very useful day today. Thank you.
Thank you, sir. Thank you so much for explaining the framework of 6G as decided by or agreed by Working Party 5D of Study Group 5 of ITUR, sir. And you also said about policy research initiative which NTI-PRIT can take, and we, on behalf of NTI-PRIT, sir, we assure you that we will work in that direction. So thank you so much for sir for your special address. Now, may I have honor of our member services, A.K. Sahu sir, for his special address. So over to you, sir. Sir, your mic is mute.
Hello?
Yes, sir, we can hear you now, sir.
Okay. First of all, good morning to all. I congratulate NTI-PRIT for its effort in creating education and awareness about advanced technology like 6G and their use cases for various sectors of economy. In the past, NTI-PRIT has successfully conducted courses on 5G, and today it is conducting webinar on 6G usage case, key capabilities and potential technologies. This effort reflects the commitment of NTI-PRIT and DOT foster knowledge and expertise in the field of 5G and 6G technology and their use cases. The Department of Telecommunication is committed to fostering an environment of innovation where stakeholders from government, industry, academia, civil societies can come together to shape the future of telecommunication. The Department of Telecommunication recognizes the significance of 6G as the next frontier in the communication technology. 6G is not only an evolution of 5G, but it represents a shift that promises unprecedented capabilities, driving innovation across industries. It will redefine how we communicate, connect devices, and interact with our environment. This webinar provides a valuable platform to explore the potential scenario where 6G will make a difference. It is an opportunity for us to explore its key capabilities with that 6G will bring to the table, including ultra high data rate, low latency, and mass device connectivity. The telecom industry has played an important role in shaping our world from 1G to 5G, and now we stand at a point for yet another transformation into 6G. The purpose of this webinar is to explore the various features of 6G, including its potential usage scenario, key capabilities, and the technology that we underpin its development. 6G is expected to enable a multiple groundbreaking applications from augmented and virtual reality experience to ultra reliable, low latency communication for critical services like autonomous vehicle and telemedicines. Let us collectively explore the uncharted territory of 6G, paving the way future that is more connected, more intelligent, and more capable than ever before. I extend my gratitude to our expert speakers who have joined us today and all of you for joining in the webinar organized by our NTI-PRIT. Together, we will shape the future of 6G and the digital landscape that lies beyond. Thank you, and I look forward to an enlightening and inspiring webinar. Thank you.
Thank you, sir. Thank you for your guiding words. And with your permission, we will proceed for the technical session, sir.
Yeah, please.
So, sir, now time has come for the first technical session, which is about technology vision for 2030 evolution from 5G to 6G. This session will be taken by Satish Kanugoviji from Nokia. So he is part of Nokia Strategy and Technology Division and heads the standardization and industry engagement in APAC from Nokia side. He focuses on India, Japan, and Korea region. He is also a distinguished member of technical staff and senior member IEEE. In his earlier role, he has been part of robotic system research at Nokia Bell Labs, and he continues to contribute in wireless research and standard making related to mobile network. Currently, his interest is in 6G communications, and his focus on to it is in sustainable and secure networking. So With this introduction, may I now request Satish ji to give his presentation. Maybe he can upload PPT. Over to you, Satish ji.
Thanks a lot, Ashok Kumar ji. Good morning. Good morning, and also, thanks a lot for providing this opportunity for sharing our views on this very pertinent topic. So before I start with the presentation, I really want to congratulate DOT, TEC, Government of India as a whole, because of the decisive spectrum as well as decisions on the technology related to 5G. We are now witnessing kind of an a record-breaking 5G deployment. Okay, and we, based on our studies, anticipate that one of our operators will fast surpass a Chinese big operator in terms of amount of 5G data consumption per day. So this is really a matter of pride for us, because although we started a bit late as compared to the world, but now we are fast catching up. So that was the first thing. Thanking you for providing the kind of spectrum as well as global standards environment that has really enabled 5G, and that has also fueled our 6G ambitions. So in terms of 6G, also, like many decisive steps from you in terms of ensuring that we have a proper spectrum environment that will be studied as part of ITU. So making some decisive and positive contributions to ITU is also going to help us a lot in terms of creating the right environment for the 6G in India, as well as taking the same positive message across the globe. So with that, I would like to start my presentation. So I'll just share my screen. Please let me know when it is visible. So are you able to see my slides?
Yeah. Can you go to slide show more?
Sure. Yeah. So one point that was very okay. All right. So today's talk is about Technology Vision 2030, and then I would also very briefly want to touch on the aspects of how we are going to build on the success of 5G to realizing this technology vision, ultimately with 6G being one of the prime enablers. And my expert speakers, colleagues, Professor Kiran Kuchi, as well as my friend Puneet Rathod, will be talking about more detailed aspects of it. There was an interesting thing that was told by Mittalji in this opening note, that we should have technology not as the end, but as the means to achieve an end. So in that context, I wanted to touch upon, as a background, I wanted to start with what would be the goals of the future society that we target with these new technologies. So we are already experiencing connectedness. We are able to talk to each other, but then this connectedness should lead to a feeling of togetherness. We should not feel just connected, but then we should feel as if we are able to interact in the same way as if we are physically close by with each other. And then information to knowledge. As you might have realized, there is umpteen number of sources from where we get information, but whether that gets available to us as some kind of knowledge in terms of allowing us to execute certain actions to our benefit, improving our lives, is something that will probably happen once we have introduction of this analytics, artificial intelligence that would convert this information into some useful knowledge. Okay. And then finally, one of the key goals of our society is to move from efficiency to purpose. So we have, currently technology that allows us to be more efficient, as in like do more within like lesser time. But in the future, there has to be a purpose associated with it. If we want to become a $1 trillion economy, so $5 trillion economy. So there, one of the major aspects is that we have to have key technology enablers that will actually help us improve the productivity across different sectors. Okay, and that productivity increase has to come bearing in mind that we do not adversely impact environment, particularly having the goals of energy efficiency and other forms of sustainability in mind. So with these three pillars as the background, I would like to move on. So what are the, so what is it that we need? So what does, so what do these goals translate into in terms of actual instantiation on the ground? So this translates into, so this translates into better experience and more productivity. Okay, and this can be in the domain of industries. This can be in the domain of enterprises, where we have, better ways of interaction between people, collaboration. Then in terms of industrial productivity, this is about creating processes that will enable us to interact with machines better, reduce the wastage in terms of design. And then also finally, in terms of consumer related use cases, we would have better ways of communicating with the environment, getting information about our surroundings so that we could lead our lives in a better way. So essentially, we are looking at enhancing consumer, enterprise, as well as industrial productivity. And a general term that we typically hear when we talk about technologies that will enable us to better interact with our surroundings, whether it is in this industry, enterprise, or the consumer domain, is the metaverse. So essentially, we are going to have metaverse enabling the kind of goals that we want to have in our society in the future. Going further. So metaverse is a buzzword, and there are different meanings that people impress on it. So it is like blind man and the elephant also in some sense. So depending on who you are, you would have different definitions. So just to set the context, I wanted to use this slide to indicate what we mean by metaverse. So from our perspective, so we have been doing research on metaverse over the past 5 to 6 years. And we have come up with two essential components of metaverse. So one is about physical digital fusion, which is to say that we can create or in fact recreate the kind of interactions between the actual physical objects, whether they are parts of machine, whether it is an automobile, or whether it is state of a telecommunication network. So that state of the physical entity should be created in the digital world, because in the digital world, then we can apply the different tools that we have in terms of, testing, recreation, time scaling, so that we can interact and predict what would be the behavior if we have so and so changes made into the physical world. So without actually impacting the physical world. So that is one very critical aspect, that we should be able to replicate the physical environment in the digital world, as well as be able to interact real time between the digital world and the physical entity. The second aspect, which is a very critical aspect, is about human augmentation. So as you know, humans have developed like lot of ability. Okay, and many times we are able to overcome the limitations of our senses as well as our motor organs, which can be, say, for example, hands or legs or whatever. So what we envisage is that we should be able to leverage metaverse to see beyond what our eyes can afford, to hear what our existing ears can afford, to be able to touch things without the need to be actually, present in that physical location. So this kind of human augmentation that allows us to overcome the limitations of our senses as well as other human capabilities is what we call as human augmentation. So in these two components can then be applied to the industries, where we are already looking at private networks enabling Industry 4.0. We are looking at use cases related to this industrial automation, digital twin. So in fact, if you look at industries, there is already quite a bit of adoption around the industrial metaverse. And then similarly, this also reflects in enterprises as well as in the consumer domains. Okay. So it is not that metaverse is something a part of the future, but if you look at the current traffic trends, metaverse and its precursors, which is what we call as AR, VR, XR, even in the current day, already are accounting for the majority of traffic in the network. So in fact, wherever we see that there is a need for increasing capacity, so these applications, which are the precursors to the metaverse, that are actually pushing. So this slide I want to show, indicating that when we are talking about metaverse, it is not in thin air, something that we are like imagining, but we see trend towards that in the current networks itself. So essentially, if you look at metaverse, there are different aspects of the physical world. Then there are, so there are different aspects of the physical world. Then you have the stakeholders which have to, collect data from the physical world, apply the different AI related, technologies to actually make sense of the data. So those kind of inferences and data have to be used by the large ecosystem of the developers so that we could develop useful applications. And all these things, since they have to operate at scale, we need to have, cloud technologies to be in the center of it all, while taking into account sustainability and also consumability into account. So when I say consumability, this is about making these services available to all, irrespective of the kind of devices, location, or the kind of context which they are operating. So this is about ubiquitous connectivity, as well as about ubiquitous availability of the technology, depending on the needs of the user. So as you can see, for enabling a metaverse, it is not just one stakeholder. So if you look at this block here, which is of course, primary interest for the audience here, which talks about 5G Advanced and 6G. If you look at that, is just one piece of the puzzle that would be required to be solved to ensure the future experience. But in fact, there are a slew of many players, multiple stakeholders that have to work together so that we can achieve the metaverse of the future, to achieve essentially the goals that we have for the future society. So with that, in summary, I just wanted to first lay the background of, what is the technology vision. So the technology vision is that we would have digital physical fusion enabled. We would have augmentation of human capabilities, which would be kind of liberating humans from the constraints that are there in terms of their existing perception, their existing location, their existing abilities to do certain activities. So these two pillars will require a multi-party value ecosystem. Okay, and to create such a transformed network in an open, innovation focused multi-party ecosystem is our vision of how the technology will evolve in the future. So that sets the background in terms of what we are targeting, what we think is the goal that we have to reach. Going further, I will talk about the different technology enablers to realize such a technology vision. Okay. So as you can imagine, if you want to continuously sense the physical world, it would require capabilities of the networks which are beyond what can be currently supported. So this would probably include support of traffic, which would be way beyond what our networks can currently do. And if such high amount of traffic has to be then consumed, then we have to have different KPIs for the network energy efficiency. So if you see, this inner ring is what 5G supports, and to enable the network transformation, 6G has to stretch the boundaries of what the network can support in all the different dimensions. And then, so what this green color entities indicate is that which use cases would be stretching which kind of capabilities, which is to indicate that not all the capabilities would need to be supported for all the use cases at the same time. But thankfully so, depending on the kind of use case that we are looking at, there would be certain capabilities that would have to be extended more as compared to the others. Okay, so for example, if we talk about remote collaboration, interacting with the digital twin of a physical machine, latency would be the critical dimension that would have to be enhanced. If we are talking about computer vision, the peak data rate would be a critical aspect, along with the reliability of the data, so that you don't have lot of loss over the network. Similarly, if you are looking at volumetric video, immersive AR, immersive experiences, which are enabled by the use of augmented reality, virtual reality. So then user experience data rate is the one that would be a critical aspect that needs to be enhanced. So now to achieve this, how do we go about? So we already know about the classical wireless system design principles, right? So we always measure our networks on the 3 KPIs of capacity and throughput, reliability and latency, scale and flexibility, which also formed the pillars of our 5G systems. But as we look to become more ambitious to support metaverses of the future, we need to go beyond the traditional KPIs, which is that we have to talk about sustainability, because as soon as we talk about increased data rates, it should not come at a cost of, say, for example, consuming all the resources in terms of energy for just supporting such high-speed networks. So our networks have to become more sustainable. We need to have digital inclusion, which includes both connectivity to all those that require those services. So when we talk about digital inclusion, it is not about having the network available in the middle of the ocean. It is about having the network available to the quality that would address the needs of those particular consumers, whether they are machines or humans. So this could include getting a good voice quality inside a lift, which unfortunately we don't have till day. I mean, we get breaks, etc. Also, this could be support of basic applications in remote areas. So rather than talking about ubiquitous connectivity in terms of just trying to ensure connectivity where we do not have connectivity currently, we have to talk about different gaps in the existing network in terms of service delivery, and we have to ensure that services as required by those people have to be made available to them. So this is our way of understanding digital inclusion, as well as ensuring the right connectivity to the different stakeholders. So then often we have seen that security and privacy always becomes an afterthought. Since our lives will be so much connected, we have to ensure that security and privacy are incorporated as part of design from day one. So while we talk about how the new technology would be able to, say, for example, allow me to measure the different parameters that I have on my body, and then give me, immediate feedback in terms of what I should do in terms of leading a good life, what I should do in terms of warning me of any impending health hazard that I might get into. So all these things are possible only if I trust the devices that I'm going to use. If you are not able to trust the device or the information that you are going to get, if it is subjected to people with malified intentions being able to kind of like corrupt it, then I can assure you that this technology will be dead on day one. Therefore, security and privacy, which was always an afterthought, would be something which have to be supported from day one. So then going ahead, if you look at, again, thanks to, a lot of participation from people from India, as well as, globally other stakeholders. So all these aspects are now part of IMT 2030 framework. And now that we have done this, we have to move ahead in terms of how we realize this particular framework, building on 5G and then evolving to 6G. So if you look at 5G already supports many of these use cases that are going to be enhanced in future. So we already have support for the high quality video in 5G, which will then be enhanced to support fully immersive user experience, XR related use cases as part of 5G Advanced. And then finally, when we go to 6G, we would be able to support holographic transmissions. Similarly, as I indicated, digital twinning in terms of industries that are already using it for automation is already supported by the existing technology. But then if you have to expand it to scale, okay, for say, for example, supporting a large number of machines that actually collaboratively talk to each other, we would need further improvement in technology that is being, discussed as part of 5G Advanced. And then finally, if you need to have real-time synchronous updates between the digital world and the physical world, for that, you will have to go a step further and beyond, and that is what 6G is going to provide us. Similarly, data communication control is already supported as part of 5G. And then which means that network is essentially a medium for us to, exchange data. But then 5G Advanced already talks about additional capabilities that will come from the network. Say, for example, precise location, timing services that are very important for extending the benefits of 5G into the industries. And then finally, 6G is going to provide completely new capability of being able to sense the environment, adding a sixth perception that would really augment many of the use cases. Plus the things that leverage artificial intelligence, which would allow us to manage such a complicated network automatically on its own, based on just intents given by the humans. So as you can see, 5G is kind of a building block. 5G Advanced is the stepping stone ultimately to realize some of these very sophisticated use cases as we get into 6G. Okay, so this slide I will just very quickly skim through. So this talks about how the existing 5G network has actually evolved across the different releases. So we have 5G release 15, which is the basic release that provided enhanced mobile broadband, with the subsequent releases that provided capability that would be very much needed in terms of industrial applications, URLLC. So we have features that we call as radio boosters, uplink improvements, for example, automation and energy saving related aspects are already being discussed as part of 16, 17, and 18. Support for new verticals. For example, we have this V2X, vehicular communication, high altitude platforms, incorporation of satellite as a possible way of delivering 5G services, support for drones. All these new verticals are being, are being supported as part of this evolution that we have currently. IoT optimization, reducing support of devices that would have reduced capability so that they can consume less power, become more cost effective. Support of newer capabilities beyond communication is already part of the 5G evolution. And of course, we talked about extended reality, augmented reality, virtual reality as well. So now, going forward, I mean, people sometimes ask, what is the difference that we see from the existing 5G to 6G? I mean, we already support digital twin. What is the new that will come as part of 6G? So this slide actually tries to give a little bit of flavor in terms of what is the new thing that we are going to get in 6G as compared to 5G. So I'll just take a couple of examples. So we have remote monitoring guidance that is already supported as part of 5G Advanced. While going to 6G, we will be able to support, because of this higher reliability that we anticipate from the 6G network, to support real-time remote control of the machines. Okay, we are able to support augmented reality games. Dynamic creation of digital worlds, interaction with them is something that would be supported by 6G. We already have non-uniform coverage with 5G, ability to integrate different kinds of networks, whether it is satellite networks, whether it is unlicensed networks, or whether it is high altitude platforms. So this would then ultimately, as we go into 6G, ensure that we have got global coverage. And when I say global coverage, it is again, talking about ensuring that we have the right connectivity to support the right use cases. And that would, of course, include us. So that would be enabled, by including technologies that would help us smartly to share the rare resources of spectrum and the RAM. Okay, so this is for the wide area. A similar flavor is for the campus. So we have, we talk about precision localization already as part of 5G. And then finally, when we go to 6G, it is not just localization, but we'll be able to find out what is the shape of the object, what is the speed at which it is moving, what is the kind of material, what is your heart rate. So, network, in addition to just providing your position, will be able to provide many other parameters of the objects without the objects themselves needing to have some kind of sensors. Similarly, we have support for the low power IoT, reduced capability set devices in 5G. We will evolve to support of zero energy devices that would be able to just harness energy in the environment to keep running. So this is to provide a flavor of what is it that actually changes when we go from 5G to 6G. Then, so this I just want to briefly present. So these are the different fundamental technologies, technology categories, I would say, that would enable us to support the future applications. So we have AI-enabled native area interface because of the different kinds of bandwidths, different kinds of hardware in the devices, different kinds of application mix. It would be very difficult to actually predetermine what would be the most ideal interface. So therefore, we are going to leverage the use of artificial intelligence to determine whatever is the most appropriate air interface technology, physical air technology for that mix of applications and devices. We talked about network providing the capability of additional sensor without the actual devices, having any capability. And this could, say, for example, be used to, count the number of humans in a stadium without the humans themselves having the sensors, or to figure out aspects like, what is my data rate without me having to embed a sensor in me. Okay. Then we talk about extreme connectivity, which is about industrial networks. Say, for example, network inside a car or inside a factory, and that should be, provide visibility to be connected by the macro network. Then, since there are so many sophisticated features, we also have cognitive, automated, and specialized architectures. So the use of AI to ensure that we will be able to manage such complicated networks. Security, trust, and privacy is going to be needed from day one. Spectrum technologies, which allow us a smarter way of sharing the networks, is going to be a key as we go into 6G. So now, so with this, we have seen what are the goals, what are the kind of technology components that we would need to support the needs of society in 2030, how the existing 5G builds over to 6G to support this. But then as we go ahead from now till say around 2030, to build the technologies that can support the services at a scale, collaboration is the key to success. And why I say this, I'll just explain in my last few slides. So as you can see, there are different initiatives that have already started across the globe. For example, in the US Next G Alliance, EU HexaX, as well as various different initiatives that we have in India, which are already looking at candidate technologies that would be part of 6G. So we as Nokia are very proud to be part of many of these alliances, and in fact in leading positions. And we would be, very happy to share experiences from our participation in these different forums to ensure that we also expedite our 6G journey in India. And then, so this also involves working with the different stakeholders, whether it is CSPs in terms of figuring out what is the potential of different technologies, or whether it is between the different industrial partners to see what indeed would be the use case, how effective it would be. Say, for example, terahertz related communication sensing is something that we are showing as part of our Stuttgart Arena 2036. And then we are working with different CSPs because they bring actually lot of knowledge from the pains, and also being very much closer to the customers. What are the real pain points or the needs of the customers? So we should not try to build technologies just because they are very challenging, but our policy is to actually work very close with our ecosystem partners to understand what are the real needs and try to build technologies to those specific needs. And then of course academia is a very key thing. Okay, and we are going to hear some interesting technology that is being developed by my colleague Professor Ken Kuchi. So like that, we are also involved. So with a host of universities across the globe, okay, because we don't think that we understand what is needed and we will specify. So we believe really in terms of collaboration, learning from the different stakeholders in the ecosystem to develop component technologies that will ultimately be serving the needs of the future. And then finally, there has to be a kind of harmonization across the different players, because only then we will be able to create the right ecosystem of devices, get the best of world to India, get the best of India to the world as we get onto this journey of 6G. So finally, so we are all very happy with the successful organization of the recent G20 summit that happened. In fact, is like happening until November in the presidency of India. So the main theme is very interesting. So we have So our motto was this particular thing, which is very common for us, but is very pertinent in this existing situation in the world. So we have this Vasudhaiva Kutumbakam, so which means one earth, one family, one future. So if I may add to this, we as India looks to lead the world in the future in terms of political, commercial aspects, also in terms of technology. If we have to lead, we have to lead by example. We have to lead by collaboration with the world. So therefore, development of technologies as well as standards in collaboration with the global bodies, which is in fact exemplified by the recent signing of this MOU between India as well as US, between our Prime Minister as well as President Biden, is a very good example of how we should execute our journey towards the leadership in 6G. So with that, I would like to conclude my session, and something that was actually mentioned by our CEO is also very pertinent. So we live in a very fragmented world. So our CEO has said very rightly, geopolitical tension shouldn't fragment the world, because irrespective of whatever differences we have, machines would speak the same language, even if the people don't. So this is a very pertinent thing, and very much in line with Vasudhaiva Kutumbakam thing, which also applies to the development of technology of India with the world. Okay, and we at Nokia will. This is our company motto, and we would be more than happy to share information and work with the different stakeholders as we take the subsequent steps in the development of 6G vision for India. Thanks a lot. Namaste for your time. I would like to conclude my presentation now.
Thank you, Satish ji, for a very, very interesting session. And talked about Nokia's 6G vision. We also talked about what are the different key value drivers of 6G. Talked about what exactly is the difference in 5G and 6G in respect of some of the use cases. We also talked about how collaboration is important for rollout of 6G. So thank you so much. And there is one question in the chat box. In case you have the access of the chat box, Satish. Yeah. So I request that in the interest of time, if you can answer that particular query, very simple query we have, and maybe other participants would be asking. So continuation of this now, we'll go for the next session, technical session 2 of the webinar, which is on potential technologies of 6G. And today we have Professor Kiran Kuchi from IIT Hyderabad. Sir is also founder of Big6 Networks, and all of us know him. Sir do not need introduction. So without wasting much of the time, I hand it over to Professor Kiran Kuchi for his session. Over to you, sir. We can see your PPT. Go ahead, sir.
Thank you, sir. Can you hear me well?
Yes, yes. Your voice is also pretty clear. Please go ahead, sir.
Thank you. Thank you for all the previous speakers for setting the tone for this webinar. I want to talk about more about candidate technologies rather than the vision and requirements, because this has been very well covered. That's what I would like to do in the next 10-15 minutes. This has been discussed, the timelines for the IMT 2030 projects. It's a 10-year project. We are somewhere in the early stages of this project, where Working Party 5D has released the framework and vision and requirements. So there's a lot of work ahead. One has to set the requirements, technical performance parameters for the standards that will come in 2030. In order to do that, I think the engineers who are working on this technology should have a clear view on where we are headed and what kind of performance one would like to achieve out of this IMD 2030 system. So it is a good time to ask, now that the framework and vision and requirements are released, how are we going to meet, how are we going to set these requirements, and how are we going to meet those requirements? This is what I would like to ask myself and maybe, present some views. This is a picture taken, people were very happy in this picture because in this meeting 44, the vision and requirements was agreed. There was a lot of hard work and a lot of sometimes uncertainty whether this meeting will produce a consensus document, but that was achieved. India, for the first time, had a big footprint in defining the vision and requirements in an IMD system. This was not the case in IMD 2020. India did not have the influence to define the vision requirements of, although there were some contributions made in the later part of the IMD process. Vision and requirement is a very important exercise. It will set the tone for what we want to accomplish. When 6G is built. Ubiquitous connectivity is something that was not there before the meeting 44 in Geneva, and it was India's heavy push, a result of a negotiated deal between India and US. And of course, there are other players who contributed to this that finally brought ubiquitous connectivity into the vision and as a prime usage scenario, as you can see. Every dot here is an extremely important usage scenario. You can also see that ubiquitous connectivity here does not refer to a non-terrestrial network. Ubiquitous connectivity here is referring to terrestrial ubiquitous connectivity. Although the vision document makes a reference to interworking with other networks such as satellite. But just to be clear that ubiquitous connectivity here we mean by terrestrial ubiquitous connectivity. Okay, so let's keep that in the back of our mind. I'll skip all these different goals and applications envisaged because this has been well covered. I'll jump right into the capabilities of IMD 2030, what we have today and what needs to be done in the next year or two. The green color capabilities are those that already existed in IMD 2020, also known as 5G. So all those green color points already existed, but every capability has an associated metric, some number associated with reliability, 10 raised to -5, -6, -7, something like that. Latency, 1 millisecond, 0.1 millisecond. So Working Party 5D was able to define a range of values up to meeting 44. And then in the subsequent meeting, this range of values more or less will be converged to a single number in most cases, which is called the technical performance requirement definition. So this is still a long exercise, and this is what needs to be done. And this can only be done through research, prototyping, and having an understanding of what kind of technology that we are going to define. So this triggers a lot of R&D. And also there are these blue colored items. They are new. They're new and they are specific to IMD 2030. For example, coverage. Coverage is not defined, is not part of IMD 2020 capabilities list. And it took a lot of effort from India to introduce coverage as a prime capability in 2030. Okay. So once a coverage metric is defined or some guidance is given, the standard has to ensure that such a coverage is met. There are also other capabilities like artificial intelligence. These are, not really measurable per se, but I think there is an expectation that some new technologies will find its way into 6G, example, artificial intelligence. Then interoperability is also a new capability introduced. This refers to interface interoperability. The interoperability between different, possibly different subsystems of a radio communication system. So something like ORAN, which is really all about interoperability, interface interoperability, it has found its way into as a prime capability. This is the story about IMT 2030 as we know today. These two pictures kind of tell us where we stand today. My interest has always been, at least on a personal level, what is that we do that we did not, what is that we know that we did not know 3 years ago or 10 years ago? That is when we define the same metrics in IMT 2020. What is that that's been learned? That's always a puzzling question. What is this that's new that's going to make its way into 6G? That's the most puzzling part. If you look at, if you heard a series of presentations made over so many years about 5G, you would remember, URLLC, massive MTC, EMBB, so many different things talked about. And what's that new? What is that is new that's going to come up? That's really an interesting question. So while I don't really have a full answer, but I'll try to answer to the extent I see this. Okay. The way I understand these IMT processes, IMT starting from IMT 2000, that's the first one that was defined by ITU. What I see is that from GSM to 3G to 4G to 5G, one of the largest contributions made by the standard, apart from enabling various services, is an increase in the speed, the connection speed. It started at hundreds of kilobits per second, or even lower, all the way till today to gigabit per second or multi-gigabit per second through 5G. This is made possible only through bandwidth, spectrum. So there are only two, the way I understand, there are only two key matters at hand: spectrum and the advances in semiconductor technology. These are the two key elements that drove the previous generations of standards. Will it be the same going forward? To an extent, yes. But then there are some hard questions we have to ask. From 800 megahertz till the mid-band auction, the golden piece of spectrum has been auctioned. So where will 6G operate? In a macro cellular network context. If you take the phone and move around, still we have difficulties, at least in India, making reliable and high quality phone calls and do web browsing. Though 5G is launched, still there are early days. Where is this new spectrum? How will we ensure that wireless communication is reliable? How can we ensure that we get high speeds using large enough cells? We can't expect cell sites to be placed every 30 meters or 50 meters. As such, today the cell sites are placed every 200 to 50 meters. So these are the questions that are very important questions one has to ask. And the answer seems to be that we have more or less hit the limits of what we can do with the mid-band. If you do a speed test on your phone, and if you do it like 10 times during the day, you'll see that you'll get very high speed, good speeds in the downlink, and bare minimum speeds in the uplink. So already we have an issue. We have a serious issue, and we have an issue that we should recognize and think about and talk about. The handset power is limited, and the information carried by the electromagnetic waves up till mid-band, we're already seeing that we're hitting the limits. So going beyond 3 to 4 gigahertz frequency range and making systems operational, reliable, achieving high speeds and achieving all these targets that we want to achieve is going to be a tall order. Okay. So I'll jump right into, I'll take a few minutes. I'll jump right into some technologies, some hints of what could be done to get to reach where we want to reach in IMT 2030, or at least fulfill these ambitious requirements, there is a requirement that the spectrum efficiency for 6G should be on the order of 3 to 4 times, or at least 3 times, or 2 to 3 times compared to 5G. That's not going to be very easy to achieve, and there is an expectation that coverage will be significantly enhanced. That's not going to be very easy to achieve, especially there's not a whole lot of good spectrum that can offer very high speeds. So this calls for a significant amount of research and development in the next few years. We can't just get a threefold increase in spectrum efficiency very easily. 5G itself had a threefold spectrum efficiency increase over 4G. Now, what is that we know now that we did not know, a few years ago? This is something we have to think about and ask. So we did some experiments on using large antenna arrays, new antenna structures, and it seems like as you move into slightly higher frequency bands, beyond 6 gigahertz, 7, 8, 9, and so on and so forth. The good thing is that you can pack a lot of antenna elements into a reasonably small space, but then you also need large antenna structures. I mean by large physical aperture of the antenna to get high capacity. This is something we tested, we understood, we proved. We'll show you some results. But the pitfall is going to be that you need physically large antenna structures. How to build them, how to build the radios is still a work in progress. So the good news is you can get higher capacities, much higher capacities, but that's not going to be, there's no free lunch. So that you have to do a lot of hard work in building these systems in a power efficient manner, low cost manner. Cost is going to be a very important consideration in this whole scheme. The second part is efficiency of the energy efficiency. The macro cells are not necessarily really best examples of energy efficient systems. They consume kilowatts and kilowatts of power, and lots of it is wasted as heat for various reasons. And this is not a scalable solution. So you need systems that are not, that are highly energy efficient. In other words, every bit you transmit, you better transmit the energy associated with transmission of the bit is actually emitted, in the transmission of the bit rather than being wasted as heat. So this is very, very important consideration going forward. The reason is that you will probably see, I'll present a view that lower energy efficiency means lower cost, and lower cost implies you can actually place lots of transmission nodes at various points and improve the coverage and capacity. So that's an angle that one has to really look at. This is not something that is taken very seriously, even in 5G. There was some effort, but not really, a full-blown effort. We don't have systems operating with high energy efficiency and large coverage and high capacity. We don't have that yet. Satellites will operate independently out of Working Party 5D framework, but these systems are already a reality now, and there's a huge progress in the direct-to-satellite communication, IoT, LEO geo orbits. All of them will supplement terrestrial systems. This convergence is beginning to happen, not necessarily at the level of radio interface specification, but maybe in terms of interworking. Okay, that's probably good enough as envisaged by Working Party 5D. I will also talk about the so-called access and backhaul. I think people are beginning to realize that this separation is actually a separation between access and backhaul, especially wireless backhaul, is very much artificial. I think this is going to go away eventually. There's no such thing as separate backhaul and access in the future systems. This will probably go away. The reasons I'll explain in a moment. I'll take a couple of minutes on the background for and motivation for introducing a new waveform in 6G. We have published a paper on Bharat 6G Alliance, and this is also published on IEEE archive on 6G vision requirements and some candidate technologies. Please do read it if you're interested in these candidate technologies. Why is that there is a need for a new waveform in 6G? Well, there was a need in 5G as well, but unfortunately, the choices that have been made for the candidate selection for waveform are not necessarily optimal. A bit late in the game, India has introduced a new waveform for the uplink that is mandatory now in release 17. So, part of the problem we have solved. But still, there is another part that needs to be solved. That is, for high frequencies beyond 6 gigahertz, there is a need for a waveform that is energy efficient. You don't want, to dissipate the energy to be as heat rather than transmitting them as information. So TDMA systems, for example, GSM has done a pretty good job of energy efficient communication system. The power amplifier efficiency in GSM is close to 100%. From there, I don't know for whatever reasons, I mean, they're probably for good reasons. Today, the power amplifier efficiency in the base station is nearly 30-35%. So 70% is wasted as heat. And that increases the cost of the system, complexity of the system, and the size of the system, weight of the system. So the base stations are really bulky today, and we need to look for alternatives. I think it's time to take a long, hard look at the choices one has to make in designing base stations. The macro cells that are operational today, they'll continue to operate as they are. I don't think we're going to change them, but as we move forward, with some new decisions, some new choices have to be made. Okay? So one new technology that we have disclosed in the Bharat 6G Alliance document is a new waveform. It's an interesting one. It actually allows you to do what the GSM systems have allowed us to do. That is, you can transmit information in the most energy efficient manner and still use OFDM. So it's kind of, we started with TDMA and we ended up with OFDM, but actually we have introduced a new waveform. It can do both. Okay, I'll just show a high level picture of how this is accomplished. So information is transmitted in the leftmost side where we have data or control information that you want to transmit over the physical layer. We introduced a reference signal called DMRS. This is something that is used for estimating the channel. And within one OFDM symbol, that which, OFDM symbol is the fundamental building block of, both 4G and 5G systems. In one OFDM symbol, you can actually multiplex signals in time. This is TDMA, pure TDMA. But what you transmit and what you realize on the last arrow outside, what you see is OFDM. So we have created a system that acts both as TDMA and both as OFDM. This gives you a great deal of flexibility. And this allows you to have the flexibility you need in creation of energy efficient transmission. And at the same time, it gives you one more additional benefit, hyper low latency. You can transmit a TDMA slot with 10 microseconds, and you can achieve maybe, end-to-end latency of 10-20 microseconds. This is possible today. In fact, we're building a prototype to show that. So you kill two birds with one shot, hyper low latency, energy efficiency, and you can do, you can achieve both using one single new waveform. This is possible. Okay. And I already talked about some experiments we have done in the IIT Hyderabad campus. We showed that using a 30-degree beam, you can multiplex 10 users in azimuth and elevation using an extremely large antenna structure. This has been experimentally confirmed. After confirming this, we wanted to really understand what is the spectral efficiency gain you can achieve in 6G as opposed to 5G. And it turns out that we did very complex network simulation. This is not an experiment. We knew that, you can achieve, a tenfold, multi-user MIMO gain in 30 degrees. And in 360 degrees, you can extrapolate and how much gain you can get. And it turned out that these experimental observations were correct. And we did a network simulation. And it turns out that you can get up to 4 to 5-fold increase in spectrum efficiency gain over 5G. That's a lot of gain, but that comes at a cost. the cost is the number of antenna elements you'll use is going to be a very large number. But one good thing is that in this technology demonstration, we showed that number of antenna elements can be very, very, very large. The physical size can be very large, but that doesn't necessarily mean you are going to use a lot of RF hardware. You can actually cut it down. So you can read the paper, you can understand it. So we have already shown a path forward to achieving high spectral efficiencies, limited spectrum, maybe in 6 gigahertz, 7, maybe 6 to 7 gigahertz, or 8 gigahertz frequency range. This is achievable. Then one has to ask the hard question: if you are moving towards 6.5, 7, or 8 gigahertz, is this something that you can use to build macro cells? This is the hardest question that we have to face. And it turns out that indoor UVs can achieve 1.5 kilometer coverage in the downlink in 7 gigahertz. This is the calculation that I have. But what about the phone? Well, that's the difficult one. We reduced the transmission power, to 56 dBm EARP, and the coverage dropped to 270 meters, even for a low energy, low power base station. Then what about the phone? Well, the phone is, if it is omnidirectional, then it won't give you no more than 50 meter coverage. So this is going to be a hard one. It's going to be the most difficult one to solve. That is, how do you build a reliable uplinks at 7 gigahertz, 8 gigahertz? I'm not talking about 70 gigahertz, 30 gigahertz, 20 gigahertz. Those are all built. They're called millimeter wave. I'm talking about something close to sub-6, just a neighboring band. Okay. So this is a problem one has to solve. And the solution is out there. That is, you build a chain of relays. And these relays have to be built using extremely low cost. I'm talking about thousands of dollars, not tens of thousands of dollars. I mean, these are so-called base stations, relay base stations. So low cost systems, pole mounted, high energy efficiency, and operating at 6, 7, 8, 9 gigahertz kind of bands. I don't mean full 6 gigahertz, maybe part of it. So integrated access and backhaul exists today, but we need to retune this, reoptimize it for 6G, and that is probably where the coverage solution exists. So then I don't think there is a limitation as such achieving so-called ubiquitous coverage. You can build cells, 100 kilometers range. It's quite possible, but we have to go back and revisit the cellular topology. Macro cells is not going to be the solution. They'll continue to exist, but going forward, that's not the way to go. So you need to redefine the cellular architecture and build new systems. I'll stop here with one picture that we have. This is a 5G class of modem, or you can call it 5G advanced or 6G. We have a chip that we built that supports both satellite and cellular. This is the direct-to-satellite connection IoT, extremely low bit rate. That is, you can connect to geo constellations, but the information rate that you can transmit is going to be a few bits every now and then. So you can build, cheap IoT devices in remote areas that can connect to satellites, and you can do a lot more things, with LEO and the higher bandwidths. I'll stop here, and if there's a question, I'll be happy to do it. Thank you.
Thank you, Professor Kiran Kuchi, for a wonderful session. You started with the framework of IMT 2030 as defined by ITU-R, particularly Working Party 5D. And you also talked about the candidate technologies and the various area of work which you had been doing, and IIT would be doing. You talked about so OT, FDM, where you talked about that within a symbol, you're talking about time domain multiplexing kind of, which you're talking about will have low PAPR and also hyper low latency can be achieved. Yes, you're going beyond the symbols. So yes, definitely. You also talked about that for 6G, some next generation of IAB kind of requirement is there. And you also talked about your experiment on SMIMO and also the 6G modem. the integrated one which can receive satellite signal directly, and also the terrestrial one. So I think a lot of work you have been doing, and we all of us hope that in 6G specification or standard, which 3GPP would be working, a lot of IPR from India will go, and we will have a good contribution. So thank you so much, sir, for such a nice presentation. There are few questions in the chat box since we have time. So maybe if you can take few question and answer, like Dr. Atul is asking how OT FDM waveform is suitable for integrated sensing and communication. That is one question. And Dr. Divyang Rawal is asking whether NOMA and OTFS are also potential waveform. Sir, today in webinar, I think 50% of the participants are from different engineering institutes, so academia itself. So you'll get a lot of technical questions. So if you can answer these two questions, it will be great, sir. Over to you, sir.
Thank you, sir. Thank you very much. The first question on the using this waveform for the radar. Well, actually, I call it radar. Integrated sensing and communication. In my primitive view, is nothing but a radar technology, whether it's used in defense or whether used in the road to know the location. Radar technology fundamentally uses a pulse. You send a pulse and you send it repetitively. This is what you do. Typically a rectangular pulse, and there are spreading codes. This is the waveform for radar, a pulse and spreading codes. So if you want a waveform for radar, we can adapt this particular waveform for radar also. It can practically do what you need. You can do spreading, you can do pulse, you can do repeated. You can accomplish what you want. There is no limitation as such. So this OTFDM can give you what the radar needs. There is no limitation as such. That's my general view. The second is there are other waveforms like they're not necessarily waveforms. For NOMA is a multiple access. NOMA has been around for 10 years. It could make its way into 3GPP. People have tried long and hard, but there's no harm in continuing to try it further in 6G. So NOMA is more of a multiple access, not necessarily a waveform actually. There is something called OTFS. Well, actually, this was proposed in 5G standards, along with pi/2 BPSK with spectrum shaping and OFDM with filtering. Ultimately, OFDM with filtering and pi/2 BPSK with spectrum shaping have been part and parcel of 5G standards, and OTFS was rejected. There are scientific reasons why, because they could never really show what is the advantage. It doesn't really give you the low PAPR. So if it is not energy efficient, you're out of the game. So in my opinion, if you don't offer energy efficiency, then you have little chance of success. The second is you have to outperform OFDM and DFT ODM. So that's the answer, short and brief answer to that. Thank you.
Thank you, sir. And I have noted few of the questions from the chat box, which you can see on the screen. I think the earlier speaker has already answered first two questions. The third one, if you like to answer, there is a kind of gold rush on the implementation of satellite NTN. So where does India stand? You like to answer this, sir?
See, India has a different situation with respect to satellites, whereas the rest of the world, for example, they have already launched lots of LEO satellites, the private players, they own spectrum, and they launched LEO satellites, and there are already services offered. In India, building a satellite communication system is not the hard part, and one can always build it. But today, the spectrum ownership and the spectral licensing conditions is really a bone of contention. I think you'll know the answers in a few weeks. I think TRAI is going to issue the guidelines, and so we need to wait and watch for the policy. It's more of a policy issue, but not really a technology issue in India. So once the policy landscape is clear, I think there will be a proliferation of NTN services. But remember, NTN is not going to replace terrestrial. non-terrestrial is never a replacement for a terrestrial communication system. It is just a complementary service. This we have to always keep it in the back of our mind. They'll come in a big way, but it's a complementary solution. I'll leave it at that. Thank you.
Thank you, Professor Kiran Kuchi, for answering all the questions which came on the way. Moving to the next session. So next we have Dr. Puneet Rathod, who will be taking session on 5G advanced technologies and their evolution to 6G. We all know that Qualcomm has been innovator in the field of mobile communications for a very, very long time. So Dr. Puneet Rathod is having a 15 plus years of experience in R&D of Wi-Fi, 4G, 5G. He has a hands-on experience in modeling and simulation, etc. And he also contributes in 3GPP and our own India's TSDSI. He contribute in the World Radio Conference, rather in WRC 19. He was part of the delegation from India. So he has a very, very rich experience. He's also kind of contributed in Working Party 5D since 2018. So he has got a lot of experience. And before I hand it over to him, I thank him for answering few of the queries in the chat box. So thank you so much for that. And now I hand it over to you for your session. So over to you, Mr. Puneet. Puneet, your mic is mute. If you can unmute. Yeah, thank you.
Okay, thank you. I was
now we can hear. Yes, thank you. Thank you so much.
Thank you for the kind introduction, and I will start sharing my screen. And once that is visible, just give me a heads up so that then I can proceed.
Sure. Yeah, we can see your slide. You can try going in. OK, full screen we can see. Go ahead, sir.
OK, thank you. So once again, thank you so much for having me here as one of the speaker and also in the company of very accomplished panel speakers from the industry and also the academia. It is indeed a great pleasure and privilege to share the thoughts on from my side on this topic. In this brief presentation, I intend to cover three large category of topics: the evolution of cellular standards, the requirements that have been envisaged for 6G, and then a few design vectors for 6G. And because we have already seen very nice and detailed presentations in so far on the 6G topic and also a few of the technology elements, I will also try to cover a few additional elements which can go into the spectrum part as well for 6G. Having said that, in general, what we have seen for mobile technology evolution is the mobile technology makes a generation leap or a major leap in terms of technology, in terms of the capabilities, in terms of the services it can offer, and in terms of the utility it can serve to the larger ecosystem approximately every 10 years. Starting from 1G, 2G, 3G, and now currently we are at the cusp of having the next leap in terms of technology evolution. Also, in terms of the kind of capabilities, this is something which we have heard so many times, moving from voice to adding data capabilities to the mobile networks. And now what we are seeing with 5G is that what started as enabling more of the vertical industries and industries beyond a traditional mobile phone, 5G and 5G advanced are now expanding into even more vertical industries, and 6G will continue doing that. And a few of these are already becoming prominent in our conversations, be it automotive, be it broadcast, be it IoT, be it industrial applications, be it non-terrestrial networks. So there are so many different verticals which are now starting to utilize the mobile technology. And in terms of the evolution or the path that a technology typically takes, it follows a cycle of innovation to early proof of concepts, experimentation, going into standardization phase. After the standardization, doing early trials, and then commercialization. Currently, we are at that stage of commercialization and massive adoption of 5G. 5G advanced is currently at that stage of standardization, and 6G is we are at that initial phase, and different pieces of the technology are, so there may be certain pieces of technology which are further ahead in the cycle. And for example, we saw some very good examples from IIT Hyderabad about the early proof of concepts and research which is progressing very well, which is at that 5G advanced 6G phase. So from the ITU perspective, it has completed the vision recommendation, which is going to be the main guiding principles and recommendation based on which the entire standardization activity will proceed. There are technologies which are much further ahead in terms of invention and proof of concept, but then the overall, from a standardization point of view, it will eventually move into standardization trials and then commercialization in the years to come. The telecom industry, one of the key cornerstones of this is ensuring inter-vendor system interoperability, and 3GPP is that forum where all the innovations research is taken by the organizations and the industry worldwide. They take those innovations in a fair, transparent industry collaboration organization where these innovations become part of discussions and then ultimately become specifications for the next generation of technology. And because of this open ecosystem for standardization, the interoperability between different vendors, between a base station and a device and another device, and different elements of the network ecosystem, all of them is ensured. And this is just from the overall perspective of where we are in terms of the 3GPP standardization. We are at the very right of this chart. We are at the edge of starting discussions on release 19 and very early release 20 kind of discussions. And India just hosted a 3GPP plenary meeting in Bangalore, which concluded on Friday. And every new cellular technology, it starts with key foundational innovations without which the generation cannot work from a fundamental level. And then there are branches of the innovation which allows those innovations to continue expanding further. And then there are very specific targeted applications, which are the leaves, which are very crucial to expand that technology adoption into multiple different markets. And for example, if we look at like the overall scheme of things like waveform, the data encoding, network access, power control, the spectrum utilization, all of these are key foundational technologies. Then we look at the different verticals: broadcast, AR, VR, satellite communication, fixed wireless access, automotive. All of them become the key branches or different verticals where these technologies expand into. And then finally, there are optimization and improvements which enable these different verticals to truly adopt the specific technology into those very targeted application use cases. And a few of those examples are reduced capabilities, the RedCap, side link, and private network slicing, and so on. So while there are so many innovations that go into developing the technology, not everything is equal, but at the same time, all the innovations are equally important. And I think that is something which is also very crucial for all the stakeholders to look at when we go towards the standardization approach. We just spoke about this, so probably I'll just skip forward into where we are in terms of 5G Advanced. And 5G Advanced 3GPP Release 18 will set up the 5G Advanced evolution, looking at the already strong system foundations from 5G, including advanced uplink and downlink MIMO capabilities, enhanced mobilities, the mobile integrated access backhaul, which would have been a fixed implementation, but then taking into a mobile IAB and a smart repeater. This is also something which was briefly touched upon by Professor Kiran as well, that we may have to look IAB as not a separate entity from a backhaul and access, and it is something which is something completely reimagination of what a backhaul would look like. AI, ML, green networks, expanded side link, more precise positioning by the networks, they being among the few key innovations which are being part of the 5G Advanced feature set. Coming into 6G, the key use cases and the different use cases have been discussed very much in detail by the previous speakers. So what I can try to offer is giving one more additional perspective into the 6G requirements and use cases and the different services that 6G can go into, which is more real-time control and moving more into the different vertical industries and enhancing the end user experience. Also making it more pervasive in terms of the access of the network to the end users, and more sustainable from a societal point of view. If we go further into more details of how this may look like from a system design perspective, it will also look at multiple enablers from a more design perspective, looking at computation, AI, system resiliency, green networks, all of them as key overarching elements of the overall system. There is also an element of further enhancing what 5G already had. So if we look at the different usage scenarios, there are a few usage scenarios where 6G will further enhance what 5G already had in terms of improving mobile broadband to more immersive platforms, more virtual reality, more realistic telepresence and others. Also enhancing the IoT into much more pervasive IoT, and then and very precise low latency communications, hyper low latency communication. At the same time, there are a few revolutionary changes which 6G will bring in from the sustainability and key capability point of view. So this is just digging deeper into the different system design targets for the new 6G capabilities, from the communication, adding to the capacity, data reach, coverage, which is also something which was touched upon from the rural reach point of view. And coverage may not just be from only the terrestrial, but also from a more holistic point of view, also including the non-terrestrial communication, providing lower data rate communication, small data communication, so that there is more ubiquitous presence. So let me skip one slide and also cover something which is more fundamental to looking at the key drivers for making 6G a reality. And when we look at all these different use cases of 6G, there are a few use cases which truly stand out from a transformative requirement in terms of capacity, in terms of latency, and in terms of the amount of data that may be required to make these use cases real. And a couple of use cases which are standing out are digital twins or extended reality. And if we look at these use cases, as we go forward, these are becoming more and more real and more pervasive in how the masses may utilize them. The kind of requirement on the network in terms of data rate or throughput or network capacity is immensely large. The per user requirement also increases as a result of this. And if we look at these newer use cases, what happens is that the new use cases will not be able to completely replace the existing mobile phones, IoT, and the existing large usage of 4G and 5G. So even in terms of the commercialization of the networks, the older generation continue to operate for at least a certain amount of time. The older use cases also continue to operate for a certain amount of time. So it is not a complete rip and replace of the network as we transition into the newer technologies, which also brings into the conversation about the need of newer frequency bands to cater to these new use cases and new capabilities. One of those is adding more wider channel bandwidths in the more propagation characteristic friendly bands. And one of those bands is the upper mid band between 7 to 15 gigahertz. There is also newer capabilities, which is joint communication and sensing, which can utilize the inherent capabilities of the physical layer communication channel so that it can do both communication and sensing using the same transmission medium. And the sub-terahertz frequency ranges, which is anywhere between 92 to 275 or 300 gigahertz. And that frequency range could be one of the key bands looking at the joint communication and sensing kind of applications as well. And these kind of different use cases and capabilities would truly have give rise to demands on new waveforms, new network architectures, and also the new device architectures. And I'll just explain in terms of the spectrum why it requires such different kind of capabilities. Truly from a physics point of view, there are lower bands which are sub gigahertz with very large coverage. Then we have the mid bands, which is currently the prime band in India and also in the rest of the world for the current 5G deployments between 1 to 7 gigahertz, 3.5 gigahertz, 3.3 to 3.7 mainly, which is a good mix of both coverage and capacity. And then we have the millimeter wave bands, which will be the 26 and 28 gigahertz, which are giving very good hotspot coverage and also fixed wireless access kind of range. And then we have the newer capabilities, which as the technology is enhancing, we are seeing newer research into both the sub-terahertz and the upper mid band. And while there are all of these different kinds of spectrum, there is also key innovations which are required in how the spectrum is utilized, and all different kinds of spectrum become extremely important from effective usage of the precious resources. Traditionally, cellular network would be utilizing the licensed spectrum from an exclusive use which remains the industry's top priority. And as far as we have those spectrum which are harmonized globally, it is helping both the industry and also the overall ecosystem, including the end users, to leverage the harmonized spectrum for better and more cost-effective devices. And then we have the traditional unlicensed spectrum, which can be utilized for, say, local usage inside industries, inside the homes. For example, we have the 3GPP NR unlicensed, which can be utilized for local access. It can be utilized in the factory floor, and and also we had technologies all the way from 4G timeframe for augmenting the existing cellular spectrum using the for using the unlicensed spectrum to augment the existing licensed spectrum usage, and then uh, the shared spectrum usage is becoming more and more crucial because there are very few spectrum bands which are now exclusively available or available without any incumbents. In addition to that, 3GPP itself is also venturing into the non-terrestrial networks and communications with satellite, communication with high altitude platform systems, which is kind of a balloon which can be much lower than a lower orbit. Uh, so with all of these different kinds of uh, spectrum and the kind of usages, sharing and native sharing or more tighter sharing of the spectrum with different kind of technologies becomes very crucial as we go forward in the technology evolution. One of the uh, one of the key parts which we also have uh, as an important framework is the upper mid band, which is from 7 to 15 gigahertz. This particular band offers larger contiguous channel bandwidths of 500 megahertz, of the order of 500 megahertz, which brings efficiencies and also which is very useful to deliver the newer use cases which we just talked about. For example, the XR and also the data intensive and latency intensive applications, which is which is a good balance of the wider coverage of sub 7 gigahertz and also the benefits of the millimeter wave band, which is a very high capacity pipe. And how can this happen in terms of a real implementation? One of the hints was was shared in the previous two presentations as well, which is moving up in the MIMO technology and looking at a much higher MIMO system. And one of those technologies is Giga MIMO as well, which is expanding into the network coverage for the upper mid band, which is the 7 to 15 gigahertz, in the same form factor of a typical mid band 3.5 gigahertz antenna. So on the left, what we have is the typical size of a 256 element 3.5 gigahertz antenna. If we move into, say, a 13 gigahertz with more than 3000 antenna elements, the antenna panel size is more or less comparable. So which is moving from a massive MIMO to a Giga MIMO. And the moment we do that, we are able to exploit the newer technology by more precise beamforming and beam steering. With that, we are able to enhance the coverage, reach a longer distance. So the coverage improves. At the same time, we are able to utilize the additional spectrum to be able to give more higher capacity to those individual users. So that is what was meant by having a good balance between the coverage and the capacity by utilizing these new spectrum bands and utilizing this higher order MIMO. So while there is nothing stopping from utilizing this higher order MIMO in, say, a 3.5 gigahertz or other bands, but then we are truly depending on the physics of the aperture size of those individual elements to be able to exploit the true benefit of this of these new technologies. And one additional benefit of utilizing these newer techniques is improved coexistence with other systems. And like I was saying, that as we expand into more new spectrum bands, the incumbents or the incumbent users in these new spectrum bands also need to be protected. So while 3GPP is moving into supporting communications directly with the satellite network, but there may be traditional satellite networks which are already in operation, which may be using, say, a legacy mechanism for communication. So they continue to operate and they need to be protected. If we move into as we move into the newer technologies, the more precise beamforming and beam steering also enables tighter control on the emissions which are in unintended directions, which is the off-axis gains or the side lobes and back lobes as we may call them. So the greater amount of energy can be focused towards the intended direction of the user, and the energy which is in the direction of the incumbent user, which is in this particular chart, the satellite receiver, which can be either a GSO, which is several hundreds or several thousand kilometers away, or maybe a non-GSO satellite, which is only a few hundred kilometers away. In both of these cases, these unintended side lobes and back lobes can be controlled in a much tighter way, allowing better coexistence. So that is another advantage of moving into these newer technologies. And I was already talking about 3GPP moving into newer non-terrestrial communication networks, and this is just giving a visual idea on what are the typical distances which are involved, starting from a UAV, which is hundreds of meters, to high altitude platform systems, which is typically 10 to 20 kilometers, and the low Earth orbit or the geo satellites from anywhere from a few hundred to a few thousand kilometers. And depending on the altitude of the communication, the kind of capability that can be utilized with these kind of networks differs. So if it is a geo satellite, then obviously latency will play a key role. So then it can be only small data with higher latency kind of a usage. But then as we come closer, and for example, high altitude platform system HAPS, then it can truly be like a mega cell, offering coverage to, say, rural area, remote area, or in the mountains, and it can be near terrestrial IMT kind of an experience. And for terahertz, I already mentioned something about the joint communication and sensing as one of the use cases. But in addition to that, there may be more use cases which are currently also utilized for, say, in the millimeter wave, for example, the integrated access backhaul, and then wireless front haul, fiber to the home, or including indoor use cases like wireless data center. So I'll just take two more slides before concluding, and which is to briefly introduce joint communication sensing and what it would mean, and why terahertz is one of the key bands which may be very helpful here. In this chart, both the GNODs and the devices may utilize these frequency ranges for communication between each other, but at the same time, there may be other objects which are not communicating objects, but truly by nature of reflection of the waves and properties of the object, both the GNODs and the devices, either individually or in a collaborated manner, they may be able to sense those signals, and by characterizing the signals and the receive power and the receive signal characteristics, they may be able to make more out of the out of the entire environment in which these objects are. And this is something which is giving one more usage of the network to the ecosystem, that along with the communication, there are non-communication usages which can be utilized, like precise positioning, RF sensing, and these new class of devices also provides better use of the of the spectrum. And one of the words which was also utilized was to visualize this like a radar. So yes, this is in some sort of sense it can be called like a radar. And one element which I wanted to finally touch upon was AI and ML, which is also something which is a very key topic and discussed very prominently everywhere. Moving from 5G to 5G advanced and into 6G, the usage of AI and ML is moving from becoming more and more integrated and native to the networks, from a more proprietary implementation or more independent implementation from which was truly only an implementer's optimization in 5G time, to a more cross-node AI ML coordination in 5G advanced. And moving into 6G, it becomes more native, where it is operating autonomously between the devices and the network across all the protocol layers, and enabling the network to be in a constant state of optimization, with more native enabling of AI inside the network. So with this, what I would do is I'll just offer a few concluding remarks, which is that moving from 5G to 5G advanced into 6G, there is a continued technology evolution, and there are those foundational technologies which continue to get enhanced with every new generation. There are few fundamental new use cases which become the key drivers of both the requirements and the new technologies that become part of the new generation. And with every new generation, within 3GPP, we have been seeing that it has been catering to more and more vertical industries, moving just beyond a traditional mobile phone and just a communication medium to enabling truly society use cases, industry use cases, and different verticals. So with that, I would conclude the brief presentation and also be happy to take some questions, if any.
Yeah, thank you, Puneet ji, for a wonderful presentation on 5G advanced and also covering 6G. And as I was looking at your presentation, some of the key points which you said is like not all innovations are equal, and you said that there are some innovation which are foundational in nature, and I know Qualcomm is known for that. And you also talked about that in 6G there'll be a certain new capability which are beyond communications, and you also talked about positioning and sensing. These two examples you gave, and you also talked about various spectrum which would be required for 6G, not only the current spectrum which we know we are using, but the new one. And you also talked about importance of upper mid-band frequencies, which is required for the capacity, particularly in the urban areas. So that's a very, very important issue for regulators, licensors like DOT, and also for every country across the globe. So thank you for bringing that point. And we heard about Giga MIMO. So appears to be something new, which may be part of 6G. And you also talked about spectrum sharing. So spectrum sharing has been in place since long, but you're talking about native spectrum sharing. The standard itself should have provision for spectrum sharing. So that's a new point. And as in 5G itself, we have started talking about integration with NTN, right? And terrestrial network, satellite and all. And in 6G, perhaps it will take a shape, or it may be available in a very native way. And you talked about AI/ML. So AI/ML has also been, it's already there and in use by many, even in the mobile technology. But you're saying that it will become native to the standard itself. So that's the new point you have brought. So with such a wide variety of aspect, you talked about 5G Advanced and 6G. Thank you so much, Puneet ji. So we'll take few of the questions which are in the chat box. Maybe I can read for you, and maybe you can try. So Chanchal is asking, do you think that RIS, that is reconfigurable intelligent service, is going to be one of the technology in 6G?
Yes, thank you. I will probably merge the second question as well, which is cognitive radio.
Yeah. Okay.
So okay.
Yeah.
So yes. So reconfigurable intelligent surface. Yes, that is definitely something which is being very heavily discussed. There are a lot of research papers about it. This is something which may truly become one of the key technologies uh, which uh, which allow us to further enhance the nature of the wireless propagation medium itself uh, to increase the coverage and capacity. Currently, we are limited to just exploiting the reflections and the multipath from the base station to the user device. But if we are able to further utilize this and have a surface, and we are able to configure the reflective characteristics of the surface, then it may be very fundamental change in how we are able to utilize the multipath. For the cognitive radio, that is something which is a question which both the research and standards will have to continue discussing and deliberating upon. But truly, from the nature of technology itself, from as I was saying, that there are from the three different categories of spectrum, dedicated spectrum or licensed spectrum may be the first and foremost key driver, which may be the topmost priority from the industry perspective as well. The unlicensed spectrum, again, it's very clear that it is it can be utilized from a traditional multiple access or a carrier sense perspective. And then the shared spectrum, the definition or how that shared framework evolves, that is something which will have to be very carefully considered, because cognitive by nature itself, it, it doesn't give a very clear idea about availability or assurance that the spectrum will be available when you need it. So that is something which may continue to be under discussion.
Yeah, thank you, Puneet ji. So, is there any more question from our participants? I think there are two more questions has come. The one is that about the full duplex mode, and other is how successful we are in terms of realizing 5G or 5G advanced KPI or target as promised. I think they're talking about ITU requirement and where we are. If you like to answer.
Yeah, I think so. I think the target KPIs. I think this is something which I would say was in the first couple of slides where I was referring to the whole 10-year cycle, from the vision and the requirements phase, which is very early in the cycle, going into innovation, standardization, and then commercialization. As we go into the commercialization phase, we start looking at the availability of spectrum from the regulators auctioning, the operators acquiring that spectrum, and then rolling out the network, and then the end users truly utilizing the newer technology devices to connect to the networks and then getting those. So the target KPIs from a ITU perspective, they are truly if we look at, say, a question answer point of view, they're truly the top marks that a technology must achieve. But if we look at what everybody from a user on an average will achieve, the target KPIs as an end user, not every user will be getting that top performance KPI. But yes, the technologies will cater to that target top KPIs, but then they will be in specific conditions.
Yeah, thank you, Puneet. So it takes a few of the evolutions of the technology to reach to whatever vision ITU creates. So on the day one, we may not have all the capabilities rolled out. So we see that every day. If you talk about peak data rate in 5G, so people are evolving and going towards that particular feature. And we understand that unless you have all the spectrum, all the MIMO configurations, then only you can achieve peak data rate, the theoretical one. But that is still, even the experimental one is a bit away. So thank you so much for answering. I think there is one more question which has come. Let us take that as a last question. So how any empirical study ever been undertaken on the effect of terahertz and millimeter wave electromagnetic radiation on humans, pets, birds? So it's a very popular question and a lot of myth roam around it. So if you like to touch upon.
I think one part, maybe I'm not the expert on this topic, but there is definitely a UN body, ICNURP, which does this study across like a very wide range of frequency ranges. And I'm sure like we do have the emission limits both on the base station side and also the SAR limits on the device side. So as we continue to evolve the technology, and I'm sure the ICNURP limits as well will continue to have their own view on the safe limits for this.
So WHO on its side have given a lot of study which has been done so far, and a lot of studies are continuing. So these impacts are very, very long term. So you can only study in 10 years, 20 years, 30 years. So that may not be years of experience or study may not be available, but I mean, quite enough things are available, and WHO have been, I mean, they have concluded that there is no, I mean, there's no evidence of the bad impact once those limitations or those safeguards which are prescribed are followed in terms of value and in terms of other parameters. So thank you, Puneet, and I think there is no more question. So we have come to end of the webinar. So finally, I would request our DDG ICT, Sri Atul Sinha sir, for a formal vote of thanks again, because now we'll be closing the session. So sir, if you are around.
Yes, Ashok.
Yeah, so I was requesting that since we are ending, so if you can have a vote of thanks for all the participants and speakers again, said sorry.
No, that's perfectly fine. It's my pleasure. Ashok, thank you, Ashok. Thanks a lot. Respected senior officers of Department of Telecommunication, different wings of Department of Telecom, LSA units, field units, officers from TEC, and participants from academia, industry professionals. Good afternoon to all of you. And it is with immense gratitude and a deep sense of appreciation that I propose this vote of thanks for this remarkable inaugural session and the complete session of the webinar on 6G user scenario, key capabilities and potential technologies. Dear participants and officers, I have already expressed my gratitude towards our Honorable Secretary Telecommunication, Dr. Neeraj Mittal. In his absentia also, I would like to express once again my sincere thanks and gratitude towards him for his keen interest, for taking keen interest in this webinar. He himself initiated that he wants to be a part of this webinar. And in fact, earlier he has told me that he would like to attain some of the sessions also to understand what is really going on in 6G. As all of you may be aware that he has joined as Secretary Telecom only 2 weeks back. But unfortunately, probably he got some pressing engagement where he told that I'll not be able to attend the seminar, but then webinar. But then he has asked NTI PRIT to give him presentations, submitting presentations, so that if some clarification is needed, he can understand. So in his absentia, I want to express my gratitude for his keen interest taken in this webinar conducted by NTI PRIT. We are also deeply honored to have the privilege of hosting such distinguished speakers, Professor Kiran Kuchi from IIT Hyderabad, Mr. Satish from Nokia, Dr. Puneet Rathore from Qualcomm. We are really, really indebted and grateful to all our distinguished speakers who have generously shared their expertise and knowledge during this session. Dear speakers, your insights have set this clarity into the minds of the attendees that what actually 6G is going to bring us to the plateau. I'd also like to express our sincere gratitude to all the participants who have really taken their time out to attend this very, very important seminar, very futuristic webinar on a very futuristic topic, 6G. As all of you may be aware that India is now poised to take global leadership position in this next G of technology, that is 6G of telecommunication technology. And therefore, such kind of awareness and discussions are very, very important for a broader understanding amongst the academia, amongst the industry, that what exactly is aspiring. We are aspiring, the standards are aspiring, the globe is aspiring to experience in the next phase of technology of telecommunication, that is 6G. And I would certainly at last like to thank my colleague, Mr. Ashok Kumar, who has always been a source of inspiration for all of us, who has always been very forthcoming in organizing webinars on very, very latest topic, who himself is a very noted academician. He has been a great trainer. Thank you very much, Ashok, to you and your team for your relentless work and meticulous planning for this webinar. We all have seen what a wonderful presentation have been given by all the speakers, all the presenters. They are certainly distinguished people in their own field, and we all attendees have been benefited by this. So my sincere thanks are also due to my Director General, Shri Dev Kumar Chakrabarti sir, who also has recently joined our organization, but he's also taking keen interest in seeing that NTI PRIT delivers at the cutting edge technologies and tries to impart the knowledge, the experience sharing with all the people at large, from the industry, from the professional wing, and also from the academia, for the latest technology, to upkeep with the latest technology. Thanks to everyone. Thanks to all for this webinar, attending this webinar. Thanks a lot. Thank you. Over
Thank
to
you, sir. Thank you, sir. And with permission of chair, we are closing the session. So thank you so much, everyone, for joining. The recording of the session will be available on NTI PRIT website shortly. So if you want to, listen it again, you can do it. Sir has also opened the video. Sir, if you like to say something at the end, few words from DG NTI PRIT, Dev Kumar Chakrabarti, sir.
Only I want to give my best wishes and congratulations for a wonderful seminar. Whatever Mr. Atul Suna was talking, just want to repeat it. So for sake of time, wonderfully done. Very nice. And I saw a number of participants almost crossing 400. And in fact, I myself also has learned a bit from the fourth session. Thank you. Thank you.
Thank you, sir. Thank you. Thank you so much. Thank you, everyone. Thank you, everyone.